Scientists recently discovered cosmic structures over 60 times the size of the Milky Way, and they were completely blown away by the sheer magnitude of these bodies. These structures defy logic and change everything astronomers thought they knew about the universe. Trying to understand their vastness will certainly leave you dizzy and weak. But before we get into it, don't forget to like the video and leave a comment after your mind has been completely blown away by the video. You can also subscribe for more cool stuff like this. Now, let's get started. Boötes supercluster. The Boötes superclusters are popular mostly because they lie next to and a little behind the Boötes void. The Boötes void is one of the most famous voids in the universe. It was discovered in 1981, which made it one of the first major voids discovered. The center of the void is about 700 million light-years from us, with a redshift of 0.052 and a diameter of about 300 million light-years. Within the Boötes, there are two superclusters that exist 1 billion light-years from Earth. The closest to Earth is about 830 million light-years away. The second one sits directly behind it at a distance of about 1 billion light-years. There has been no scientific study of the superclusters in Boötes. Although these superclusters are much bigger than the Virgo supercluster, many closer superclusters are considered more interesting. The Boötes void has been the subject of several scientific kinds of research. It was discovered in 1981 by Robert Kirshner, Augustus Oehmler Jr., Paul Schechter, and Stephen Schechtman. The scientists surveyed galaxies in 3 small parts of the sky in the Boötes void region and noticed there was a large gap where there were no galaxies. Then they surveyed the entire region over the next few years. In 1983, they confirmed the presence of the Boötes void. They published a paper in 1987 where they produced a map of the void. It didn't take long for other astronomers to begin studying this void. Soon, they discovered some galaxies within the void. J. Moody, R. Kirshner, G. McAlpine, and S. Gregory, in a paper in 1987, listed 8 galaxies discovered in this void. With these discoveries, astronomers believed there could even be more to unravel. It soon became a popular sport among some astronomers to find galaxies in the Boötes void. M. Strauss and J. Huckra announced the discovery of 3 more galaxies in 1988. In 1989, G. Aldering, G. Bothman, R. Kirshner, and R. Marsky announced their discovery of 15 galaxies. By 1993, astronomers had discovered 27 galaxies in the Boötes void. In a paper, S. Cruzen, D. Weistrop, and C. Hoops listed these 27 galaxies, but it didn't stop there. They continued to discover more galaxies so that by 1997, a total of 60 Boötes void galaxies were known. However, this is still a relatively low number. A typical region of the universe of this size would usually contain many thousands of bright galaxies. Most of the galaxies discovered are generally located near the edges of the void. So at its core, it is likely there are several galaxies still waiting to be discovered. SARASWATI supercluster. The SARASWATI supercluster was discovered by researchers from the Inter-University Center for Astronomy and Astrophysics, IUCAA. It spans an enormous amount of space, measuring some 600 million light-years across, in which the team estimates lies the equivalent combined mass of over 20 million billion suns. Aside from its extraordinary size and mass, the discovery of this structure is so significant because so far, astronomers haven't actually identified that many superclusters, meaning Saraswati is joining the ranks of some pretty elite company. Previously, only a few comparatively large superclusters have been reported, explain 2 of the team, astronomers Joydeep Bagchi and Sashir Sankhyan. For example, the Shapley concentration or the Sloan Great Wall in the nearby universe. Another unique feature of Saraswati is its far-flung perch, which sits approximately 4 billion light-years away from you and me. It is the first time that we have seen a supercluster that is so far away. One of the team, Somak Ratchaudhary, who also originally helped to identify the Shapley concentration, told Shubhashri Desikan at The Hindu, Even the Shapley is about 8 to 10 times closer, he said. The researchers located SARASWATI by examining data from the SLOAN Digital Sky Survey. According to them, the supercluster contains at least 43 galaxy groups and clusters, comprising about 400 galaxies. The most exciting thing about the SARASWATI supercluster is that its extreme distance from Earth means that the light we see has traveled an awfully long way to get here. It shows us what the supercluster looked like when the universe was only 10 billion years old. CFA2 Great Wall. Discovered in 1989, the CFA2 Great Wall is also known as the Coma Wall or the Great Wall. It was discovered in 1989 by Margaret Geller and John Huckra, based on redshift survey data from the CFA Redshift Survey. The CFA2 Great Wall is a giant galaxy filament known to be among the largest known galaxy superclusters in the observable universe. As the name implies, the galaxy is great because of how large it is compared to other standard galaxy walls. The CFA2 Great Wall's dimensions are between 50 and 750 million light-years. It is 200 million light-years in width and about 16 million light-years in thickness. The CFA2's Great Wall's point closest to Earth is around 300 million light-years, while its furthest point is about 550 million light-years away. The structure holds 3 equally massive galaxy superclusters known as Hercules, Coma, and Leo. There is no conclusive evidence on how far the wall extends because of the zone of avoidance. The zone of avoidance is a patch of the universe that we cannot see due to the light absorption in the plane of the Milky Way galaxy in which the Earth is located. The zone of avoidance is made up of gas and dust from the Milky Way. It obscures the astronomers' view, so they cannot determine if the wall ends or continues further than they can currently observe. For context, about 20% of the universe is blocked from our vision due to our galaxy's stars and interstellar dust at optical wavelengths. Astronomers can overcome this block of dust through X-rays and infrared light observations. In the standard model of the universe's evolution, structures such as the Great Wall form along and follow web-like strings of dark matter. The general conception is that this dark matter dictates the structure of the universe on the grandest of scales. Dark matter gravitationally attracts baryonic matter, and it is this normal matter that astronomers see forming long, thin walls of supergalactic clusters. CAELUM supercluster. The CAELUM supercluster is a possible massive supercluster discovered in the 1980s and extends 910 million light-years. For context, picture the Laniakea supercluster from the Great Attractor episode. It is 520 million years away and holds a mind-boggling mass of 100 quadrillion stones in hundreds of thousands of galaxies. Now that you have a good idea of what the size of the Laniakea supercluster is, let's compare it to the CAELUM supercluster. The CAELUM supercluster is 1.7 times more gigantic than the Laniakea supercluster, meaning it is almost twice its size. Its closest point to Earth is 1 billion light-years away, while its furthest point is 2.31 billion light-years away. In addition, the CAELUM supercluster holds 8,300 galaxy groups, 50,000 giant galaxies, and just about 500,000 dwarf galaxies. It is 10 to the power of 29 times larger than the Sun. PISCES-CETUS supercluster complex. The PISCES-CETUS supercluster complex was discovered in 1987 by Richard Brent Tully from the University of Hawaii. It contains our local Virgo supercluster that holds our Milky Way galaxy. Not only is our famous Milky Way galaxy located here, but the PISCES-CETUS supercluster complex also contains at least 60 galaxy groups and clusters in a diameter of 110 million light-years. It is estimated to be about 1 billion light-years long and 150 light-years wide, and is one of the largest structures in the observable universe. Virgo makes up just 0.1% of the total mass of the complex. Interestingly, the PISCES-CETUS is not the only structure that contains Virgo. The Laniakea supercluster also holds it. PISCES-CETUS is about 1 billion light-years in length and 150 million light-years in width. Its estimated mass stands around 10 to the power of 18 solar masses. According to Tully, who discovered it, the complex is composed of 5 parts, including the PISCES-CETUS supercluster, the PERSEUS-PEGASUS chain, which contains the Perseus-Pisces supercluster, the Pegasus-Pisces chain, the Sculptor region, which contains the Sculptor supercluster, and the Hercules supercluster, and the Laniakea supercluster, which contains our Virgo supercluster, local supercluster, as well as the Hydra Centaurus supercluster. The structure was named after the PISCES-CETUS superclusters, its richest superclusters. Perseus-Pegasus filament. The Perseus-Pegasus filament is a galaxy filament containing the Perseus-Pisces supercluster. It stretches for roughly 1 billion light-years away from Earth. The Perseus-Pegasus filament is considered to be one of the largest known structures in the universe. It is adjacent to the PISCES-CETUS supercluster complex. The Perseus-Pegasus filament was discovered by David Batuski and Jack Burns of New Mexico State University in 1985. Some accounts claim that Clyde W. Tombaugh from Lowell Observatory discovered its existence in 1936 while conducting his search for trans-Saturnian planets. He reported it as the Great Perseus-Andromeda Stratum of Extragalactic Nebula. Before him, Walter E. Bernheimer reported his discovery of parts of this clustering. Boss Great Wall. The Boss Great Wall is a supercluster complex with 2 elongated, 2 large, and several smaller superclusters. The Boss Survey Salon discovered this structure in early 2016 using the Baryon Oscillation Spectroscope survey. It is around 1 billion light-years in diameter and contains an astonishing number of galaxies, out of which around 830 are visible galaxies, while others are dark galaxies. The Boss Great Wall has a total mass of around 10,000 times the size of the Milky Way galaxy. Although its exact size has not yet been determined, it is safe to say this Great Wall is extraordinarily large. Scientists mainly discuss whether the supercluster complex is moving together or gradually separating as the universe expands. According to Joshua Sokol, Great Wall filaments are essential because on the grandest scales, the universe resembles a cosmic web of matter surrounding empty vids, and these walls are the thickest threads. Unlike several other chained large-scale structures, the Boss Great Wall's superclusters are much more densely packed with high stellar mass galaxies. The implication of this is that the Boss Great Wall's discovery has given astronomers an excellent opportunity to learn more about the large-scale structure of the cosmos. South Pole Wall. The South Pole Wall is a giant wall of galaxies stretching across 1.4 billion light-years. It contains hundreds of galaxies, with its largest parts sitting 500 million light-years away from the Milky Way galaxy. In astronomy, distance is measured using the redshift phenomenon. This is based on the concept that as the universe expands, galaxies recede from us, and their light stretches to longer wavelengths, giving them a redder coloring. Following that logic, the redder a cosmic structure is, the farther away from Earth it is. While scientists were still on the road to discovering the South Pole Wall, they employed a different yet similar approach to measure the distance. This technique involves measuring the redshift and the motion of the galaxies around one another as they pull each other by gravity. This technique also helped them detect the mass coming from invisible matter, which is the dark matter that influences the galaxy's movements. They could also map a 3D matter distribution in and around the zone of avoidance. Their study results in a map showing a giant bubble of material centered around the southernmost point of the sky. Researchers have found it challenging to confirm the exact points where these structures start and end. The scientists who mapped the South Pole Wall remain convinced that they have not mapped out the entire structure yet. In their paper, they mentioned that they could not fully confirm the complete map of the South Pole Wall until there was a comprehensive map of the universe. Sloan Great Wall. Located around 1 billion light-years away from Earth, the Sloan Great Wall is a cosmic structure formed by a giant galaxy filament. It was discovered in 2003 by a group of scientists at Princeton University, spotted in the data from the Sloan Digital Sky Survey. This Great Wall is about 1.37 billion light-years in length, which places it around 1/60th of the observable universe's diameter. It is approximately 500 million light-years long, 300 million light-years wide, and 15 million light-years big. Essentially, the Sloan Great Wall is a massive wall between 1.8 and 2.7 times longer than the CFA2 Great Wall. It contains many galaxy superclusters located in its densest area. In 2011, critics said that the Sloan Great Wall was not a structure in itself. Instead, it is a chance alignment of three structures. CLOWES-CAMPUSANO LQG. Discovered in 1991, the CLOWES-CAMPUSANO Large Quasar Group, or LQG, is a giant structure comprised of 34 quasars located at a distance of 9.5 billion light-years. It is around 2 billion light-years long and about 1 billion light-years wide. The CLOWES-CAMPUSANO LQG is one of the most exotic cosmic structures known to man. It is 1.8 billion light-years away from the huge LQG, another giant structure that appears further down on this list. When you compare the size of both massive structures, it almost seems as though they are in a cosmic relationship for many reasons. They are both located in a lumpy area, which is different from the norm in other regions of the same size and redshift in the universe. Some researchers have proposed the theory that since the structures are so close, they might actually be a single structure connected by undiscovered intergalactic filament, but there is no evidence to support this claim yet. U1.11. The U1.11 is one of the most massive known LQGs. It has an estimated maximum diameter of 2.2 billion light-years and contains about 38 quasars that cover a distance of approximately 8.8 billion light-years. It was discovered in 2011 by Robert Clouse during the Sloan Digital Sky Survey. Before the huge LQG was discovered in 2012, the U1.11 was the largest known structure in the universe, beating CLOWES-CAMPUSANO LQG's 20-year record as the largest known structure at the time of its discovery. Its existence suggests an evolution of a large galaxy filament. It is also located within the Virgo and Leo constellations, approximately 2 degrees away from the CLOWES-CAMPUSANO LQG, CCLQG. It is called U1.11 because it is at redshift z equals 1.11. This corresponds to a distance of approximately 8.8 billion light-years from Earth. It is adjacent to the CCLQG and is relatively close to U1.54, another LQG. The Giant Arc. The Giant Arc is a cluster of galaxies concentrated in a curvy cosmic structure extending 3.3 billion light-years in space. It is a recently discovered structure so gigantic that it challenges astronomers' previous assumptions about the cosmos. The Giant Arc is an epic arrangement consisting of galaxies, galactic clusters, and lots of gas and dust. It is located 9.2 billion light-years away and stretches across roughly 1/15th of the observable universe. According to Alexia Lopez, a doctoral candidate in cosmology at the University of Central Lancashire, UCLan in the UK, its discovery is serendipitous. Lopez was assembling maps of objects in the night sky using the light from about 120,000 quasars. These are distant bright cores of galaxies where supermassive black holes consume material and spew energy. As light passes through the matter between the Earth and the quasars, different elements absorb it. These leave telltale traces that can give researchers vital information. In her research, Lopez used marks left by magnetism to determine the distance to the intervening gas and dust. She also determined the material's position in the night sky. Lopez added that through these traces, the quasars act like spotlights in a dark room, illuminating this intervening matter. An interesting thing about the Giant Arc is that it is bigger than other enormous clusterings such as the Sloan Great Wall and the South Pole Wall, both of which are dwarfed by even larger cosmic features. Huge LQG. The huge LQG houses about 73 quasars with an estimated size of 4 billion light-years. The huge LQG was initially named U1.27 due to its average redshift of 1.27, placing it at about 9 billion light-years away from Earth. On January 11, 2013, Roger G. Clouse and his colleagues from the University of Central Lancashire in Preston, United Kingdom, reported a grouping of quasars within the vicinity of the constellation Leo. They used data from the DR7 QSO catalog of the Comprehensive SLOAN Digital Sky Survey, a significant multi-imaging and spectroscopic redshift survey of the sky. According to them, the group was the largest known structure in the observable universe. In reality, they initially discovered the structure in November 2012, but it took 2 months to verify before the announcement. Since its discovery in 2013, it has received significant attention from the scientific community. One of the reasons is that it has a whopping 6.1 quintillion solar masses. When it was first discovered, the huge LQG was identified as the most gigantic structure known to the observable universe, but it has since been superseded by a much larger structure. It is also very close to the CLOWES-CAMPUSANO LQG U1.28. Giant GRB Ring. The giant GRB ring is a ring of 9 gamma-ray bursts. An interesting thing about this structure is that it was discovered almost by accident in 2015. A team of Hungarian and American astronomers, led by L.G. Balázs, was analyzing data from different GRBs and X-ray telescopes to try to discover structures using the gamma-ray Burt correlation method. Gamma rays are emitted during a supernova if a dense star collapses. It could also suggest energy from star formation. The result of their study was the giant GRB ring. The scientists discovered a significant clustering of GRBs that occurred in a ring shape. Upon further testing and analysis of the GRB cluster, they realized that the sample had a higher concentration than the average level. It was a highly unlikely concentration that indicated yet another cosmic structure. But the supercluster can explain the significant distribution of GRBs because of its tie to star formation. Also, because the ring shape is not random, they concluded that it must be a real structure. The gamma rays on this structure are so potent that if Earth were in its path, it would most likely destroy life on Earth. The giant GRB ring is located around 9 billion light-years from Earth, and the redshift is between 0.78 and 0.86. Its diameter is about 5.6 billion light-years, which makes it one of the largest structures in the universe. HERCULES-Corona Borealis Great Wall. Gamma-ray astronomy discovered another object that would become the largest structure in the universe. It discovered the Hercules-Corona Borealis Great Wall. The Hercules-Corona Borealis Great Wall was discovered in 2013 by astronomers who used data from Swift spacecraft and found a cluster of gamma-ray bursts. The GRBs were quite close to each other and clustered in higher quantities than expected. To astronomers, this indicated the formation of a massive object. The Hercules-Corona Borealis Great Wall has a diameter of 18 to 23 billion light-years and is 15 to 17 billion light-years away from Earth. It also contains 283 GRBs. In some studies, there have been doubts about the existence of the structure. They argue that the structure was found through biases in certain statistical tests without considering the full effects of extinction. In 2020, the original group of discoverers and others published a paper that says that their analysis of the most reliable current dataset supports the structure's existence. They, however, admitted that the THESIS satellite would be needed to decide the question conclusively. An interesting fact about this structure is how it got its name. Jondrick Valdez, a Philippian teenager, read about its discovery in a newspaper and named the structure the Hercules-Corona Borealis. Later, a science vlogger used the same name to describe the structure in one of her broadcasts. The name was stamped when John Hakila, one of the Great Wall discoverers, used the term to describe it. So Hercules-Corona may not be an accurate description of the structure, but it has become the most widely accepted. And that brings us to the end of the 15 largest structures in the universe. Which one did you find truly mind-blowing?